This video, we're going to start to look at some real world stuff. So we're going to see what those slope and those intercepts and the domain and range, we're going to see what all that means in the real world. So I've taken a problem and I've already made a graph for it. Okay. So this problem represents how much money I get paid over the summer for tutoring. Okay. So if you look closely at my graph, my x-intercept is my time, and my y-intercept is my money. So this is telling me that after 1 hour, how much do I get paid? $5. After 2 hours, how much do I get paid? $10. And so on and so forth. So when we're looking at these problems, some of the key things we need to realize about them is just little things that we call characteristics of the graph. We're going to start looking at the slope, the intercept, the domain, and the range, and we're going to see what that actually means in the real world. So first thing, I'm going to label my independent variable. And remember, independent means x. So my independent variable, it's already on my graph for me, is time. Time depends on no one. And my dependent variable, which is y, is money. Okay. Is this a function? Absolutely. Why? Because it passes the vertical line test. So it is a function. Okay. So now we're going to start labeling some of those key characteristics. First one is slope. So remember, to figure out slope on a graph, we are going to look at the change in y over the change in x. So looking at that, if I start here, to get to my next point, I have to go up 1, so plus 1, and I have to go over 1, 2. I'm going to the right 2, so plus 2. Do it again. Up 1, to the right 2, up 1, to the right 2. So I can tell that my slope is, change in y is 1, change in x is 2. However, does that look right? Does this really say that if I work 2 hours, I only get paid $1? Is that what it's saying? Good job. You have to realize this y-axis is not going up by 1. How much is it going up by each time? It's going up by 5 each time. So really, even though we only went up 1 box, we went up 5 units. We went up for $5 worth of money. So it's really a plus 5 here. Same thing here. Did we really go 2 hours? No, we didn't go 2 hours. Yes, we moved 2 boxes, but we only moved 1 hour. So that's a plus 1. Same thing here. We went up $5. We went over 1 hour. So our true slope, it's not 1 over 2. We did not work 1 hour and get paid $2. That's not what it was. Our real slope on this problem is 5 over 1. The reason that is our change in y. Remember, change in y is the y-axis. So our money, this is telling us that we get paid $5, which is our change in y, $5 per 1 hour, because our x is time, hours. So $5 per hour. That's what our slope represents. We get paid, I actually get paid $5 per hour. That's what my slope represents. So now, looking at my y-intercept, we know that y-intercept is when x is equal to 0. That's when we cross the y-axis. So as I did on my previous example, I'm going to take my pencil and I'm going to take it all the way along the line, the graph, and I'm going to stop whenever I cross the y-axis. So this is where I cross my y-axis. That point is at 0, 0. This y-intercept is telling me my initial value. It's telling me how much I start off with. So here, if my y-intercept is when at 0, that means I'm starting off with $0. So I started with $0. That's what that is telling me. Now let's say I started with $5, then I would start up here. Or let's say I started with $50, I would start up here. But since I'm starting here at the origin, I know that I'm starting with $0. So, domain and range. Domain and range is going to be simple on this problem because all you're thinking about is what boundaries we have set. So the first thing we have to realize, is this a continuous or is it a discrete function? This is definitely a continuous function because our dots are connected. And we know that we write our continuous domain and range with the inequality signs. So I know that my smallest x value in this problem, can time be negative? Well, no. Time has to start at a certain time. We have to have time, correct? So our smallest x value is 0. Being that this can go on forever and ever, the problem didn't say, hey, Miss James can only work 5 hours or Miss James can only work 3 hours. No, we didn't have any boundaries set on how many how many hours we can work. So our biggest number we would call infinity. This is domain, so it is x. We can actually equal to 0 hours. Miss James doesn't necessarily have to tutor if she doesn't want to. So we can equal to 0 hours. Same thing on this side. Now this is one way we write it. 0 is greater than or equal to x. I'm actually going to take this off of here because we can't equal to infinity and we know that infinity cannot be reached. So I like to leave it like this. 0 is less than or equal to x. If you want, you could also write it backwards if you wanted to read it that way. X is greater than or equal to 0. Mind you, when I wrote that differently, I didn't change which number was greater. X was greater here. X is still greater here. I just reversed the way I wrote it.